DNA, the carrier of genetic information. Since 1866, with Gregor Mendel's discovery of how genetics are passed down from generation to generation, scientists have been fascinated with discovering the DNA and its structure. After the discovery of DNA's double helix shape with Rosalind Franklin, James Watson, and Francis Crick, the National Institute of Health and Department of Energy decided to set up the Human Genome Project in 1990. In April of 2003, scientists were able to map out 97% of the human genome, allowing researchers to discover more than 1,800 genetic diseases. On an episode of 60 Minutes, Eric Lander, famously known as a lead scientist for the Human Genome Project, mentions that the discovery of a sequence of base pairs in the genome allowed them to discover all these genetic diseases. However, they did not know how to fix them. Today, scientists are using CRISPR to find cures for these diseases.
Say I am a patient who has cystic fibrosis. Could CRISPR go into my lungs and snip out the bad gene that causes the disease?
Well, we know that's caused by a particular gene, and we know that in most cases it's a particular misspelling of the gene. 3 letters are missing. In that case, what we need to do is not clip out the gene, but replace that bit that has a little deletion with the right sequence. As a physician scientist, you might say, could I make a virus that could be sprayed into the lining of the lung that would infect the cells and carry with it a CRISPR with the extra 3 letters or sequence to be inserted in the right place? And if you got into enough cells, that would probably be a pretty good therapy for cystic fibrosis.
The CRISPR process actually comes from a bacteria's natural defense system to protect themselves from a virus. When the bacterium is first infected with the virus, it keeps record of the virus's DNA to detect it again later on. When the bacterium detects the DNA of a virus, it produces 2 strands of RNA. One of these strands contains the DNA of the virus, acting as the guide RNA. When this RNA replaces itself with the virus's DNA, the RNA can cut the viral DNA, killing the virus. Scientists discovered that this process can be used in humans as well. Once inserted within the nucleus, CRISPR locks itself on a specific sequence, and the DNA is unzipped so that the target RNA can connect with the DNA. Then, Cas9, an enzyme that acts as genetic scissors, cuts the DNA. However, researchers have to use CRISPR to find specific mutations. Using CRISPR, researchers can insert a new DNA strand, eliminating the mutation from the DNA. Although CRISPR is a scientific achievement, it has faced controversy, especially regarding the ethics behind this process and the risk of designer babies. Many people see this technology as playing God, especially in the case with reproductive biologist Shukrat Metopolyov. His research is how to correct this gene using CRISPR in human embryos. His hope is to prevent genetic diseases that are passed down from the parents onto the child before developing in the womb. However, many people fear that this research will lead to designer babies, where parents get to choose the genes that are seen as better, whether that be that a child is taller, smarter, or even with a certain hair color.